Hello students, this is Zilasli Physics, lecture number 2. Before that, I request you to like, comment and share. Subscribe this channel please. So we are doing physical quantities. Anything that can be measured is a physical quantity. Distance is a physical quantity. We can measure distance. We can find time by clock. So time is a physical quantity. A care and love for child is not a physical quantity because it cannot be measured. Units. Units are a system of measurement. Generally, we follow two systems, MK system, CGS system, meter, kilogram, second for MKS, centimeter, gram, second for CGS. From MK system comes SI system, system international units or standard international units, coulomb, C, SI unit of electric charge, symbolized as Q. So coulomb electric charge is measured by coulomb. Two like point charges, positive and positive suppose, or negative and negative, equal magnitudes 1 and 1, placed in a vacuum, distance of 1 meter from each other, repel each other. They will move away from each other with a force 9 into 10 to the 9 Newton. Each charge is called as 1 coulomb. We call each charge as 1 coulomb. The charge of an electron is 1.6 into 10 to the power minus 19 coulomb. The magnitude of charge on a particle is given by formula. Q is equal to NE. Therefore, N is equal to Q by E. Therefore, N is equal to 1 coulomb divided by charge of an electron 1.6 into 10 to the power minus 19. That gives N as 0.625 into 10 to the power 19. So we can also write N is equal to 6.25 into 10 to the power 18. Volt V's. SI unit of potential difference, symbolized as V. Is high voltage danger. Volt is a unit for measuring potential difference. Volta, scientist who discovered voltaic cell. Circuit consists of cell with positive and negative terminal. V as the potential difference. Now see, current is flowing. Charge Q is flowing. W, work done in moving the charge from positive to negative terminal. So the potential difference measures V is equal to W by Q. Volt is equal to joule per coulomb or joule by coulomb. So we say 1 volt is equal to 1 joule per, or 1 volt is equal to 1 joule divided by 1 coulomb. So how we define 1 volt? 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. So 1 volt, 1 V is equal to 1 joule per coulomb. So 1 millivolt is equal to 1 by 1000 volt is equal to 1 by 10 to the power 3 volt is equal to 10 to the power minus 3 volt. 1 kilovolt or kV is equal to 10 to the power 3 volt. 1 millivolt is equal to 10 to the power minus 3 volt, and 1 kilovolt is 10 to the power 3 volt. 1 megavolt is equal to 10 to the power 6 volt. Now ampere, symbolized as A. SI unit of electric current I. Ampere is the unit for measuring electric current. Yes, there's the name of the scientist, Ampere. Positive and negative terminal. So Q amount of charge, electric charge. It's flowing in time t. So the formula for electric current, I is equal to Q by T, or rate of flow of charge Q, time t. So electric current is equal to electric charge divided by time. So we measure electric current by ampere. So ampere is equal to coulomb divided by second. So 1 ampere is equal to 1 coulomb divided by 1 second. So we define 1 ampere. 1 ampere is constituted by the flow of 1 coulomb of charge in 1 second. 1 milliampere, 1 by 1000 ampere is equal to 1 by 10 to the power 3 ampere is equal to 10 to the power minus 3 ampere. Now match the following. In column 1, electric current I, number 2, electric charge Q, and potential difference number 3 as V. And in column 2, so the units, joule, B ampere, C coulomb, and D volt. Answers. So electric current, ampere A, electric charge, coulomb C, potential difference as volt V. The numerical, Q is equal to I, we are using the type A, Q is equal to I T, W is equal to VQ, and Q is equal to NE. Question number 1. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So the given quantity, current I is equal to 0.5 ampere, time t is equal to 10 minutes. So convert it into SI unit, 10 into 60 seconds is equal to 600 seconds to find charge Q. So Q is equal to, put Q is equal to question mark. Now using the formula, Q is equal to IT. So Q is equal to IT. Q is equal to I into T. Now we put the values, 0.5 into 600, that gives Q as 300 coulomb. The charge flowing through the circuit is 300 coulomb. Question number 2. How much work is done in moving a charge of magnitude 2 coulomb from a point at 118 volts to a point at 128 volts? So given charge Q is equal to 2 coulomb, potential difference V, 128 minus 118 volt, that is 10 volt. To find work W, so we put a question mark here using the formula. W is equal to VQ W is equal to VQ, W is equal to 10 multiplied by 2. So the answer is W is equal to 20 joule. The work done is 20 joule. Next sum, question number 3. Calculate the number of electrons constituting 1 coulomb of charge, or show that 1 ampere is equivalent to flow of 6.25 into 10 to the power 18 elementary charges. This is a very important question. So given charge on an electron E is equal to 1.6 into 10 to the power minus 19 coulomb. It's not given, but it's implied. So we put the value. We know this. Charge Q is equal to 1 coulomb. So that's given. To find number of electrons small n is equal to question mark. Formula Q is equal to Ne. Solution Q is equal to Ne. Therefore, N is equal to Q by A. That is 1 by 1.6 into 10 to the power minus 19. Therefore, N is equal to 6.25 into 10 to the power 18. That's the number of electrons. Considering 1 coulomb of charge is equal to 6.25 into 10 to the power 18. Question number 4. How much work is done in moving a charge of magnitude 2 coulomb across 2 points having a potential difference of 12 volt? Given charge Q as 2 coulomb, potential difference V as 12 volt. To find work W, this question mark is there. So we're using the formula W is equal to VQ. Solution W is equal to 12 into 2. Therefore, your work done is 24 joule. So the answer is the work done is 24 joule. Now question number 5. How much energy is given to each coulomb of charge passing through 6 volt battery? Given charge Q is equal to 1 coulomb, potential difference V is equal to 6 volt. To find energy given by the battery is W, or work done is equal to question mark. Formula W is equal to VQ. Solution W is equal to VQ. Therefore, W is equal to 6 multiplied by 1 is equal to 6 joule. So your answer is the energy given by battery is 6 joule. Question number 6. How many electrons are flowing per second past a point in a circuit in which there is a current of 5 ampere? Given current I is equal to 5 amps or 5 ampere times small t is equal to 1 second. Charge on electron E we know is equal to 1.6 into 10 to the power minus 19 coulomb. To find number of electrons N is equal to question mark. Formula Q is equal to Ne. Sorry, I'm very sorry. So Q is equal to IT we are using because current and time is given. So Q is equal to Ne also. Solution Q is equal to IT. This is equation 1. Q is equal to Ne. This is equation 2. From the equation 1 and 2, if you compare the two equations, we find IT is equal to Ne. Therefore, N is equal to IT by E. Therefore, N is equal to 5 into 1 divided by 1.6 into 10 to the power minus 19. That gives you N as 31.25 into 10 to the power 18. So your answer, electrons flowing per second, is 31.25 into 10 to the power 18. So here we have used two formulas. Q is equal to IT and Q is equal to Ne. Question number 7. An electric heater is connected to the 230 volt mains supply. A current of 8 ampere flows to the heater. Two questions are there. Question A, how much charge flows around the circuit in each second? And question B, how much energy is transferred to the heater in each second? Given potential difference V as 230 volt, current I as 8 amps, time t, small t as 1 second. To find charge Q, question mark, energy W, question mark, formula Q is equal to IT, W is equal to VQ. Now solution, A part, Q is equal to IT, therefore Q is equal to 8 into 1. Therefore, Q is equal to 8 coulomb. Now part B. W is equal to VQ. Therefore, W is equal to 230 into 8. Therefore, W is equal to 1840 joule. So A charge flowing around the circuit is 8 coulomb and B energy transfer to the heater is 1840 joule. Thank you very much from Seriously Physics. Hope you have enjoyed the video.